This conference will now be recorded.
Welcome everyone to today's SCLF webinar. I'm delighted to introduce David Pearks from SEPA, who's doing our presentation today. I'll give him a proper introduction in a wee minute. Just to let you know that our next webinar will be 2 weeks' time, and it will be Paul Bardos from Surf UK, and he's going to be talking about the revised Surf UK guidance. Before I introduce David, as you know, all our presenters are invited to nominate a charity, and David has nominated WWF, so I'll be putting a link to that in the chat in a wee minute. So if you are able to make a donation for that, it would be very much appreciated. So just to introduce David then. So David is a senior hydrogeologist at SEPA. He has over 25 years experience working in geoscience in the public and private sector, involved in site investigation, environmental and geotechnical monitoring and risk assessment. And over the past 5 years, his focus at SEPA has been on land contamination and brownfield development. And today David's going to take us through some practical aspects of groundwater sampling. So without further ado, I will hand over to you, David. Thank you.
Great, thanks, Alison. Hello everybody, and thanks for attending to listen to my talk today. I work within the Water Resources Unit, which is part of hydrology within SEPA. We provide advice on site investigation, risk assessment and monitoring to our regulatory colleagues. We're also involved in strategic work, monitoring and reporting on the state of the water environment, and catchment scale initiatives to improve the environment and bring in measures to deal with pressures. So just as a little bit of a starter, just to mention a little bit about how SEPA has been changing over the last 2-3 years. You may be aware that we're trying to introduce a slightly different approach where SEPA's looking at focusing more on wider environmental issues such as climate change and developing the circular economy, in addition to the traditional role of regulating point source emissions. So we've developed the sector plan approach, which I think you may have heard from Murray Dobson on this a little bit from a few months ago. So the aim of the sector plan approach is to try to bring obviously to try to make all businesses compliant, but also to try to make as many as possible to go beyond compliance. So land contamination is a cross-cutting issue which forms part of many of these sector plans. And I think that probably brownfield development and promoting the sustainable use of land are key elements in the transition to one planet prosperity. So I'm not going to say any more about that, but there's quite a lot of information on SEPA's website basically about the sector plans and the new approach. So if you would like to find out more, then you could look on there to see what we've got there. So in terms of what I'm going to talk about today, so I want to give an outline of the fundamentals of groundwater sampling, so try to briefly cover all the key elements. It's a big topic, so we're going to have to push through things quite quickly. There's obviously specialised areas that I'm not going to cover. So health and safety, obviously an important thing, but I'm not going to cover it today. And QA and QC procedures for sampling have been mentioned in previous SCLF sessions, so I would cover those. There's also biosecurity and specialised sampling, which I'm not going to look at. But in terms of what I am going to look at, I won't read it all out, but reasons for sampling, going through considerations, planning considerations, how you would go about doing your sampling, and then what comes at the end, things like decommissioning, and a little bit about SEPA's data management, SEPA's monitoring and how to find SEPA data. So the first consideration, I think, when we think about sampling groundwater is obviously why do we want to sample it? What is the legislative context and the environmental setting? So these things need to be thought about first. Reasons range from national scale monitoring, such as what we do for WFG classification, also regional baseline studies, the type of work that the BGS does. We also may want to sample groundwater, obviously, for investigating contaminated sites or for doing compliance monitoring for operational sites, we need to provide the data to be able to do adequate risk assessment. And then at the other end of the scale, of course, we've maybe got pollution incidents that we might need to deal with, or waste crime incidents, so we need to collect samples in order to provide evidence for those types of situations. So the reasons might be obvious, I guess, but I think it's always worth thinking about where the projects might be going and what data sets might be used in the future as well, in order to maximize the value of those data sets. The reasons that you're sampling also would determine the best techniques and approaches that are suitable, and also the levels of acceptable uncertainty that is going to be associated with your investigation. There's an awful lot of guidance out there on groundwater sampling. You could probably spend a lifetime reading it if you wanted to do that. But the key things, I think, the key points or the key area documents to provide guidance for most people are probably the British standards. And certainly for us, they're probably the most important source. So we've obviously got 5667 Code of Practice for Site Investigation. 10175 for contaminated site investigation, which tells you quite a lot about sampling at contaminated sites. But if you really want to get some detailed specific guidance, then you need to go to the 5667 series, which covers water sampling in many different situations. There's a lot of parts to this series, but there's 4 there that I've highlighted, which are the key parts that you need to look at for groundwater sampling. So you've got part 1, which provides general guidance on setting broad objectives, and how you should think about accuracy and precision and that kind of thing at the start of your investigation. And then part 3, about preservation and handling of samples, which is relevant to groundwater as well as all other types of water sampling. Part 11 is probably the most useful specific guidance on sampling of groundwater. And part 22 also very useful on designing and installing monitoring boreholes. There's some parts which no longer exist. You might find that part 18 on contaminated sites, which used to be part of the series, has now been withdrawn, and it's actually been replaced by part 11. So the information that was in that was incorporated into part 11. It's important to keep up to date with British standards. They do get revised and changed fairly regularly, so always make sure you've got the latest version. The Clare website's also got a lot of very useful guidance. SEPA's got guidance as well, which is relevant. So it's worth looking at guidance that SEPA produces about landfills, for instance. There's a document for monitoring of leachate groundwater and surface waters in the context of landfills, which has got quite a lot of detail, which is useful as well for other situations. And then there's of course published literature, which there's plenty of out there. Some of the manufacturers' websites are actually quite useful. The Wetera one's got quite a good list of references that you can look at. So I just wanted to quickly go over a couple of points of terminology, of course. So what is a well? To most people, it might be something like the first image there, traditional dug well with a bucket, perhaps. But a well can also refer to a spring. Scotland well is an example there in the picture and on the map. Springs are often traditionally important for cultural and religious reasons. A well could also, of course, be a purpose-drilled borehole. Usually when we're talking about a well, that's what we mean. So those purpose-drilled boreholes could be for groundwater monitoring, or they could be for water supply. And of course, in the oil and gas industry, a well is a deeper borehole, which is drilled for exploration and production. So you need to be always thinking about, what's the context that you're using that the term well in, and then exactly what you mean. Another aspect of terminology that I wanted to touch on was what is a sample. So of course, what we're talking about here is usually the first meaning. It's a small amount of something that shows you what the rest is or should be like. So we collect a sample. We want to try to find out what the rest, the larger group is. In terms of the second meaning, the sample is a collection of the first meeting. So essentially, you're taking a bunch of water samples which form a sample from the larger population, and then what we're trying to do is work out what the properties of the larger population are from the sample that we take. So I think it's important to think about what is the population as well. In the circumstances we're talking about here, the population is the set of all groundwater samples that could be taken within specific sort of temporal and spatial bounds. So obviously you could never sample the whole population, but you're trying to work out, well, what's the best way that I can collect a subsample, I suppose, of that population in order to infer its properties. And often we want to take a random sample because this gives us a well, it gives us the ability to make more reliable inferences, I think, about the larger population. Types of groundwater sampling locations. So there's a number of many different types, really. But I think the most important thing to consider really here is that there's an uncertainty associated with whichever type of sampling location you use. What your aim really is to collect a sample which is appropriate for your reason for sampling. So you may need your sample to be very reliable, or you may be able to say sample, or to give an example, for instance, in the early stages of, say, a pollution investigation or a waste crime investigation.
Oh, right, is that you going?
From a trial pit would be acceptable, just to give you an initial
Yeah,
indication
this
of the level of
webcam,
contamination.
I'm now having to listen on the phone as well as.
And yeah, and potentially surface waters may be a useful proxy as well for groundwater quality, where you can maybe infer further groundwater quality from the base flow. Usually, of course, we're talking about purpose-built borehole. So in all these circumstances, though, really you have to consider what's your tolerable uncertainty, and there's always going to be some sort of trade-off between the cost of your investigation and the reliability of your samples. There's quite a number of things you need to be thinking about when planning a groundwater investigation. So as mentioned in the previous slide, you want to try to avoid any data gaps which are going to lead to unacceptable uncertainty. So thinking it through very carefully and making sure that you avoid those things in your sampling program is a key thing. All groundwater investigations should have clear and measurable aims. There's obviously the key considerations of how many locations do you need, what your analytical parameters are going to be, sampling duration, sampling frequency, ultimately how many samples do you need to get. In terms of analytical parameters, as well as doing your contaminants of potential concern, I think it's always useful to have a good think about what other things should you be doing. We would normally say that it's useful to do the standard ions, so the full set of cations and anions, so that you could potentially characterize your groundwater in terms of standard methods like Piper diagrams, stiff plots, and those kind of things. Also, make sure that you think about doing degradation products and isomers, so such as those you would get in the PCE to ethene decay chains. And also, you may need to consider the benefits of doing an integrated investigation. So quite often we might see geotechnical investigations done alongside environmental investigations. So in many cases, that's absolutely fine, but we need to be thinking about whether or not doing an integrated investigation could potentially compromise any of the aims of the individual investigations. So in terms of monitoring network design, so the first question, how many and where should the boreholes be? This, of course, is going to be highly site-specific. Well, essentially is site-specific, of course. The conceptual site model, which has been developed at the desk study stage, is going to be your primary reference to determine that. So the location and the type of receptors as well, I think, is probably going to be a key consideration here. Different stages of investigation require different monitoring networks, of course, as well. So another key thing as well, are you at your exploratory phase, main phase, or supplementary investigations? Remediation and verification, of course, are going to probably require monitoring, and they're going to require different monitoring networks as well. So there's quite a lot of guidance out there, of course. So British standards gives you some idea of how many locations and what spacing should be, but ultimately, I think in terms of what SEPA is looking for, in terms of how we review things, we would be looking to see whether or not we can say that water environment aims have been met. So we need to make sure we've got sufficient groundwater monitoring to ensure that we understand the flow regime, the extent of the source, and the properties of the source are adequately defined, and we've got enough information for risk assessment. And we also need to make sure that we've got suitable monitoring locations to allow compliance monitoring. So it's worth having a think about where your assessment point is going to be. How are you going to make sure that you've got the information required to to determine if the site's compliant? Yeah, so the next step, borehole design. So we need to have a think about, once we've thought about where the monitoring locations need to be, exactly how are we going to design boreholes. So the key design considerations, of course, are going to be the expected depth of the groundwater that you're going to get from your conceptual site model. What's the lithology going to be? The drilling method and equipment. We also need to think about what type of installation installations we're going to put in. Are they going to be single, dual, or multi-channel? I would say that in general, there's a preference for single installations, given that they're kind of more reliable over the long term, although of course multi-channel and dual installations may be suitable in certain circumstances, but I think particularly multi-channels may not be as reliable in the long term, particularly the narrower diameter ones. They tend to be more easily damaged or blocked, so it's quite important to think about how long do you need the installation for as well. So how robust, how reliable is it going to be? Design screened interval, of course, is the key thing you need to think about in terms of what you're sampling. So we need to make sure that our screened interval is at the depth that we want to sample and in the lithology that we want to sample, in the aquifer that we want to sample. Sealing is also a key factor. So we need to have usually bentonite seals top and often in the bottom as well, to make sure that we're not causing mixing of waters of different quality from different aquifers, and also at the surface we need to have adequate sealing as well to avoid entry of surface water ingress. So usually a concrete plinth of some sort. There's always going to be exceptions to these things, but typically I would say that we want to try to avoid long screen sections because we want to be focusing on the aquifer of interest. We also, as I've mentioned, we want to avoid screen sections that cross multiple aquifers or lithologies to avoid causing mixing. Screening perched horizons can be a problem, of course, so sometimes you don't know what you've encountered until you've monitored it for a while, but obviously we want to try to avoid that, because otherwise you may find that your borehole runs dry after a certain period. And we probably want to avoid, in general, screening at a significant depth below the groundwater table, because generally where you have dissolved phase contaminants, they're going to be somewhere near the, fairly close to the groundwater table usually, although that's not always the case, of course, because if you have a DNAPL source, then it may be deeper down. But we want to make sure that we don't end up screening the borehole too deep, so that we're missing the plume, basically. And then borehole construction. So there's a number of things that we obviously need to record as we're drilling: lithology, water strikes, evidence of contamination, that kind of thing. These things are going to be dependent on the drilling method. So cable percussion will give you better information about water strikes and lithology in general than, say, drilling with rotary. So it's worth thinking about those things. it's always useful, I think, to optimize the borehole design based on the field information that you get as you are drilling. So you may want to adjust the level of your screen section slightly based on what you find. So the groundwater might be a bit shallower or a bit deeper than you expect, or you might find that the lithology is not what you expected either. So it's ideally, I think we would be trying to optimize those things in the field if possible, to avoid installing the borehole installation being less than, or being not as well optimized as it could be. The headworks are important, as mentioned, so to avoid surface water entry, they need to provide protection and security. So we need to often put a concrete ring round or a fence to avoid vehicle damage or damage from animals. They need to be very clearly marked with a unique borehole number. This is often an issue on operational sites where borehole names and numbers get confused. So I'd say that was one of the key issues really that we need to try to improve sometimes. Post installation, the development of the wells is an important step in cleaning it out to be ready for sampling. So that involves pumping it at a higher rate than you would do for sampling or purging for a period to clean out the fines and any drilling fluids that are still in there. And then it's very important, of course, to make sure that you survey in the as-built locations of all of your monitoring locations and level them to preferably to meters above ordnance datum coordinates on the British National Grid, and then all that information transferred onto clear and detailed borehole logs. So make sure information is not missed off. So preferably we want to see the coordinates and levels on the logs, and also the water strikes and that kind of thing, and the results of any field tests like PIDs and that kind of thing. So everything on there, so it's all together. And then there's the water sitting in the borehole after it's been developed. Is still, well, it may not be representative of the surrounding aquifer conditions because of various reasons, primarily stagnation, oxidation, and loss of volatiles, or potentially debris falling into the well. So boreholes needs to be purged before sampling, which involves pumping the borehole to remove the water from the borehole and induce flow from the surrounding formation. So we should be doing some sort of form of purging unless the boreholes and wells are in continuous use for abstraction. So for instance, if you were sampling a shallow well which is used as a water supply, then we wouldn't normally purge it because you should be getting a continuous flow going into it already. Purging strategies are dependent on a number of things: borehole construction, what the well yield is, and what type of sample you're looking for. Generally, for SEPA, we're talking about wanting to get an integrated or composite sample, so we would use volume purging. The British standard for volume purging is to remove 3 times the filter pack volume from the borehole, which can be a substantial amount of water. That's not always appropriate, of course, so sampling contaminated sites, you may be wanting to use low flow purging techniques instead, where there's concerns over, for instance, if volume purging might mobilize contaminants. There's quite a lot of useful guidance in 566.7.11 on purging strategies, and also in the CLARE TB03 document, so recommend looking at those to decide how to approach it. Well yield is a consideration. Sometimes wells will purge dry before you could remove your full 3 times filter pack volume. So in those circumstances, usually the best approach is to leave the borehole to recover for a period and then sample later. Often it's better to return the following day once the groundwater level's recovered. So this equipment they use for purging and sampling, there's quite a lot of different types of pumps and ways of getting water out of boreholes out there, but the choice of equipment essentially dependent on hydrogeological conditions, borehole construction, and the purpose of monitoring. The contaminant type is also an important factor, so certain types of pumps are not suitable for certain types of contaminants. A typical, in terms of equipment, balers and depth samplers are sometimes useful. Balers are quite useful for sampling shallow wells, but less useful for sampling boreholes. Typically, the way boreholes are sampled is using an inertial pump, which is a very simple foot valve with a ball bearing in it, which connects to a stiff tubing, which, when the tubing's moved up and down, water enters at the bottom and is gradually moved up with each up and down stroke. You can use a power pack shown in the picture there, which will move the tubing up and down for you, clamps onto the head of the borehole to take the effort out of using inertial pumps. There's quite a lot of advantages to using inertial pumps. I mean, you can leave the tubing in situ. You don't have to worry about moving stuff from one borehole to another. But there's also considerations of, what's the capacity of the system, what flow rate can you get out of it. So there's a diagram there sort of indicating that basically you need to be thinking about what the different diameters of tubing, the different systems can provide different flow rates and different are able to raise the water from different depths. So you need to make sure that that's suitable for what you want. There's other types of pumps, surface pumps, inertial pumps, and peristaltic pumps are useful where you've got shallow groundwater, but they can only draw water from a head equivalent to 1 atmosphere. So essentially that's limiting them to about 8 meters of lift. Submersible impeller pumps are a larger pump which goes down the borehole, where you have an impeller and a motor, electric motor, which is down inside the borehole. These are available at a lot of different power levels and pump rates are possible. So these are this is the type of equipment SEPA generally uses to sample our boreholes. And of course, on the bottom there, I forgot to mention, always wear gloves to avoid cross-contamination. So you should put on your gloves before you start purging, basically, as well as for sampling, just to ensure that we don't have any problems with cross-contamination. During purging, there's quite a number of different things which are useful to record. So before you start dipping the well, check the groundwater level is useful. Dipping the base of the borehole may also be useful, but you need to be careful that if you're doing low flows, purging and sampling, you probably don't want to do that because you're going to be disturbing the borehole, any sediment in the base of the borehole and also the water column. So that's not advised for low flows, purging and sampling. If you've got any free-phase NAPL present, use an interface probe, of course. It's not usually a good idea to try to sample groundwater through a layer of free-phase NAPL, so you're probably better to stop there and review your sampling strategy. During purging, I think it's useful to estimate flow rates and purge times. These could be useful to compare between different sampling rounds to see if anything's changing, and also to see if there's any significant difference between different boreholes, perhaps boreholes installed in different units, different pathologies. It's also useful to keep a regularly dipping the groundwater level as you're purging, to make sure that the drawdown is not putting the pump at risk of drying out, and also useful to record the appearance of the purged water. Are you seeing any changes as you're purging? What sort of olfactory and visual evidence of contamination is associated with the purged borehole, purged water, sorry. The weather conditions as well. Sometimes if you get a heavy rainstorm, for instance, during purging and sampling, it may be something which is going to be, may affect the sample, so it's worth keeping a note of that. After purging, as we said, if you're volume purging, you may have hundreds of litres of water, purged water to dispose of per borehole, so that needs to be appropriately collected. Quite often the best solution is to put it into an IBC, but whatever solution you choose, I mean, it's going to be dependent on the site setting and the level of contamination of the purged water, but it needs to be careful. It's often a consideration which has quite major consequences, I suppose. It's something that needs to be planned for, basically, that to make sure that we know what we're doing with that purged water, and it's going to be disposed of in an appropriate way. And then all that information needs to be presented, or preferably presented in a detailed sampling report. So moving on to wellhead measurements. So we can measure a number of different physicochemical parameters at the wellhead. The key parameters are DO, EC, and temperature. If we monitor for temperature, we can then calculate percentage saturation for dissolved oxygen, for instance. The parameters they will change as you're pumping the borehole, as you're purging it. So you can use monitoring these wellhead parameters to indicate that the borehole's been adequately purged for sampling. So often that's something that we might do if it was low flows sampling and purging and sampling that we're looking at. When we're volume purging, we still may want to do wellhead measurements. So those would be recorded after you've done the full volume purge. There's also potential additional parameters, pH, redox, stability, that you could look at doing as well. These ones are a little bit more problematic. The probes tend to be more temperamental, more difficult to get reliable measurements. Wellhead measurements should always be done using a flow-through cell. So this system shown in the picture there, where the water flows through and allows a laminar, like a smooth flow across the probes, basically. So what you don't want to do is cause aeration of the water, or overly or expose the groundwater to the air, to oxygen as before it's passing over the probes, basically. So you want to make sure that you've got a smooth flow and your wellhead measurements are reliable. So you shouldn't be using something like a bucket. So putting the groundwater into a bucket, for instance, and stirring the probes in the bucket would not be a reliable way to do it. So but as I've said, you can use wellhead measurements to indicate that purging is sufficient based on the parameter stabilization. DO is usually the best parameter to use because it's the last to stabilize generally. If you're going to do If you're doing that, you need to decide on what the stabilization criteria should be. So what's the percentage it would be between one measurement and the next. So for example, the Clare guidance suggests dissolved oxygen plus or minus 10% of the reading, or plus or minus 0.2 milligrams per litre, whichever is greater, between individual measurements. So it's worth looking at that TB03 to get further guidance on that. Actually doing the sampling, so you may want to use the same equipment or different equipment for your sampling to purging. So there may be flow considerations here, so you may want to maximize the flow that you're getting. So maybe using a fairly large diameter inertial pump, for instance, to do your purging, and then maybe you want to use a different type of pump, for instance, a peristaltic pump to do sampling if you're sampling for VOCs. Peristaltic pumps are quite useful for that, in that they don't, there's no contact with the, as the water's flowing, there's no contact with any parts of the pump, basically, apart from the tubing, and you can provide a smooth low flow for VOC sampling. As mentioned, always wear gloves. Filtering is necessary, of course, if you want to do dissolved metals. I've got another slide coming up on that with a bit more detail. You need to make sure you use the right bottles. There are many bottle types out there. SEPA has a bottle atlas, which has got about 30 bottle types for freshwater sampling, and even more additional ones for marine. So yeah, and also preservatives might be used. So for instance, acidification for metals. So you need to make sure you know whether or not these preservatives are pre-charged in the bottles. And generally, you want to rinse the bottle and cap the sample water, unless there's some pre-charged preservative in there, because obviously you would want to rinse that out. Usually you want to fill the bottle to the brim unless otherwise specified, but in some circumstances you may not want to do that. So that's a general bit of general sort of advice, but obviously if in doubt you should speak to your lab and make sure you know what's required. I put a slide here about filtering. You need to basically think carefully whether or not you need to filter, I think, because there's some, you may have turbidity in your sample through other reasons other than precipitation. So I think essentially there are other ways to deal with the problems of turbidity in a sample, and I think kind of you need to make sure that you've exhausted all those other ways of dealing with it before you decide to filter. So sample turbidity could be due to less than optimum well construction. So maybe you could develop your well a bit more by pumping it to clear out the fines, or is it something to do with your sampling technique? Have you disturbed the fines at the base of the borehole? I think there's a risk that if you do filter, you might be removing something from the sample that you want to be in there, like particular material that exists naturally in the aquifer. So yeah, essentially think carefully about it, I think, and if in doubt, analyze both filtered and unfiltered and see what the difference is. Filtering is obviously only appropriate for dissolved metals. You wouldn't be doing it for samples that are going to be analysed for organics or VOCs or other organics, because there's a risk of, well, you would be losing analytes from the sample due to absorption on filter paper, and also possibly due to volatilization. So if you do decide to filter, the British standard is 0.45 micrometers. It is definitely recommended to do it on site immediately after sampling to avoid filtering out metals that have precipitated out after sampling, and preservation by acidification needs to be done. I think there was a bit of discussion. I missed the SCLF session when this happened, but there was a bit of discussion about filtering recently from a couple of months ago. So there was a paper that circulated on filtering, which I've put a reference to there, which provides a bit more information. So this sample transit, preservation, handling, this has also been covered by previous SCLF sessions, but just to briefly recap, sample chemistry might change after sampling, so we need to keep samples cool and dark transit. It's quite important to consider holding times. So if you're sampling for VOCs, for instance, good idea to try to do your sampling early on weeks so that you make sure that the samples get to the lab and get analysed before exceeding the holding times, which could be 2 or 3 days, and also consider the weather conditions you're expecting. If adverse weather is expected, then it might be a good idea to reschedule, because you don't want to put all that effort into collecting your samples and then find that they get delayed or lost on the way, as we did a couple of years ago. I don't know if anybody remembers the Beast from the East, but we lost, well, the samples were delayed basically due to that, and we missed quite a lot of holding time because of that. On leaving site, always it's a good idea to dip wells again, just to make sure that nothing's changed, and check for blockages, particularly if you're sampling somebody else as well. So then you're basically checking to make sure that it's not you that's caused some damage to the well. Make sure that everything's replaced back, borehole covers, caps are securely in place, and remove everything from the site, including any waste. So I put in a little bit about decommissioning here. There's some SEPA guidance on decommissioning out there from SEPA and Natural Scotland. Basically, redundant wells and boreholes, as it says, need to be suitably decommissioned to avoid causing preferential pathways for contaminants to groundwater. We really, in general, we want to decommission by backfilling with a low permeability material. In most circumstances, if it's a monitoring borehole we're talking about, then that's usually the way things are done. But we need to think carefully about what material is being used. So the material shouldn't leach hazardous substances or cause pollution. yeah, and then in certain circumstances, sometimes it may be necessary to backfill with material that tries to mimic the natural permeability of the ground. There may be circumstances where the well itself may disrupt groundwater flow, so you may want to try to do that. In terms of licensing, I just put a little bit in about this. I'm not going to go into a lot of detail, but GBR4 and abstraction regime of CAR is usually what's going to cover you for doing sampling, purging and sampling. So this is, so you would be within the GBR as long as your borehole or monitoring borehole is not more than 200 meters deep, which is pretty unlikely, and as long as you're not abstracting more than 150 cubic meters per year for purging and sampling. So in most circumstances, this is going to be sufficient for any sampling program that's planned. There's also GBR16. I haven't reproduced that in full there, but that's another one which needs to be thought about. This covers direct discharge of substances to groundwater, which may be used in borehole construction and decommissioning. So it depends on what you're using to backfill your borehole, and also to use during the drilling process. So in general, it's okay, but certain substances, such as grout-containing blaze, you need to have a registration for, or you need to speak to SEPA about. So I would say have a look at the CAR practical guide on the website, and speak to SEPA if there's any doubt over this. Of course, as was mentioned in a previous SCLF session, if we're talking about remediation, then that's a different situation, and you need to have a mobile plant license under WML, which would then cover any licensing requirements and any CAR licensing requirements that might be needed for the remediation. So I put a quick slide in about data management reporting. I mean, this could be a whole session in itself, but just as a few key points that I thought I might raise. So we need to make sure that we've got a suitable platform to put our data into. Spreadsheets are not always the best way. They can be prone to errors, and if you've got large data sets, it can be tricky to manage everything. So I would recommend thinking about could a database and a data visualization application be a better way of doing things. There's always potential issues of determinant names changing and units being inconsistent between sampling rounds. This is something that we often have problems with. So make sure that those, that you know how you're going to deal with those things, basically. Table formats we're thinking about. I'll put an example there of a narrow version format table, which lists each test result per row, which I would say there's a lot of advantages to doing this, in that you can then attach to any additional fields or flags that you want to put on for each test result. So for instance, have you decided that might be an outlier, or what is the result less than the LOD? Those kind of things is useful. Quite often we see the typical way of doing it is in a cross table. I think that's got its limitations, basically, and it's sometimes difficult to deal with the data in that format. And you can also always recreate the cross table format if you want it by pivoting on a narrow table format. Reporting, it's always useful to think about what you're doing for that. I think reporting aggregated data is generally what we ask for. So sometimes, we might see reports for individual monitoring rounds or individual years, but I think it's important to put the data into context so we can look at longer term trends. Summary statistics obviously need to be generated, but it's important to think about, are there any step changes in the data? That means that we need to divide it up into different periods to make sure that we're not producing misleading statistics, and things like how many LODs are in the data set. Is it, are the statistics potentially misleading because of that, because they're 90% LODs or something like that? we need to consider how we're going to deal with trends and outliers. Sometimes you don't know the reason for an outlier, but you could clearly see that it's not characteristic of the rest of the data set. So it's, I wouldn't say get rid of it entirely, but flag it up, and then we can consider how what the effect on the statistics of having it or not having it. Time series plots need to be clear and useful for interpretation at an appropriate scale, appropriate colors, that sort of thing. Sometimes we see plots that are not, basically not suboptimal in terms of, what we're illustrating what's going on. So we need to make sure that they're optimized. We'd like to see digital data as well, and everything should be supported by lab results sheets. Just a quick bit on SEPA's groundwater monitoring network. So the key drivers for us, of course, are WFT, RBMP classification, and we've got a network of something like 350 sites currently. These are mostly concentrated around the east coast and the central belt. This is because of where most of the pressures are, but also where groundwater is used as well. So and also where the most productive strata are, of course. The network is largely private, so we rely on cooperation and working together with landowners and industries that use groundwater in order to collect our samples. We've also got 11% of the network SEPA drilled and installed boreholes in areas where we have greatest pressures, I suppose, in terms of usually diffuse agricultural pressures, where we need additional boreholes. So SEPA doesn't have a lot of money to spend on drilling its own boreholes, but we have a small amount which is available to do that. And we also use Scotch Water and Coal Authority locations as well. The main thing that the data is used for is to undertake WFT classification, 300 bedrock and 103 superficial groundwater bodies in Scotland. The groundwater bodies were revised back in about 2012. There was an older set which you may see still out there, so it's on certain websites. I have seen things submitted with the old groundwater bodies fairly recently, so I would say it's important to make sure if you're putting that type of information in reporting, make sure that you've got the most up-to-date set of groundwater bodies. The classification tests that we do are divided into quantitative and chemical. Saline intrusion, surface water impacts are included in both because they have aspects of quantitative and chemical impacts. But the key one really is the general chemical test. So this is overall impacts on a groundwater body. So we undertake the general chemical test for a set of selected pollutants. Most of these are diffuse pollutants, so we're talking about nitrate and pesticides, but we're also recently added a few other substances where we have impacts due to larger contaminated land sites. For those, we've added TCE and benzene and a handful of other contaminants associated, with urban pressures. And then at the next level down, we group the next level down below the table there. We group them in terms of priority substances, specific pollutants, and other substances. And then the substance level is one level down beyond that. And then everything gets aggregated up on the WFT one out, all out system. So if one test fails, this passes upwards and causes the tests above to fail as well. Where to find SEPA data? So I was just going to put a few links in here. So we've got Spotfire tools available on the SEPA website there at the Water Environment Hub, Classification Hub, which can give you details of groundwater bodies and classification, pressures and measures, all that kind of thing. There's an environmental data list as well, which is on the website, which some of those items take you to links where you can download data sets. You've got on the Scotland's Environment web as well, there's a map available of water monitoring points. This is of some use to show you the distribution of monitoring points, but the amount of there's not much attribute data there to tell you what the monitoring points are or what they're used for. So I think you can. There's also a shape file that can be downloaded that can be plugged into any GIS in order to provide a bit more information about those water monitoring points. And then if you need to have, if you're looking for analytical data or groundwater level data, the way to request that is through the website, the online form. So just put the details in there of what you're looking for. So I just added a couple of 3 take-home messages here at the end, just to highlight that. I think probably the main things from our point of view is to make sure that the borehole location and construction is suitable for the investigation aims. As I've highlighted before, we need to make sure that all monitoring locations are surveyed in adequately and uniquely labelled. And I think also it's very important to think carefully about the most robust and efficient way to manage your data. So that's the end of my presentation. So thanks for listening, everybody. I hope that was useful and interesting. And anybody have any questions?
That's great. Thank you very much, David. That was very interesting. Very thorough run through groundwater sampling. So thank you very much.